So hi everybody, thanks for joining. Before I pass over to Nikki, I'm just going to give a very brief introduction to our group, Safe Landing. So Safe Landing is a group of aviation workers. We're campaigning for long-term employment, and we're doing that by challenging industry leaders to conform with climate science and to reject what we see as dangerous growth. So part of what we're doing is we are, equipping and informing aviation workers with best possible information from different specialists. Something that we're really keen on campaigning for is trade unions to run worker assemblies where we can do this sort of thing in a more structured way, and get specialists in, to talk about climate science, the impact of aviation, some of the technology options, some of the policy options, and then come to informed recommendations based on deliberation, consensus, and voting for recommendations that trade unions should be taking on in terms of what we think is a truly sustainable future for the industry. So our website is here, it's safe-landing.org, and you can always email us on that email as well, which is on our website. But yeah, that's enough about me. We've got Nikki here, and she's from Zurich, and she produced a really interesting paper which was covered in New Scientist, and so she's going to talk a bit about that, and also her background is in carbon removal, so there'll be a bit on that as well. Nikki, would you like to introduce yourself? And
sure. Yeah, thank you so much, Finlay, for inviting me today to speak. I'm really excited to be able to talk in front of you. As I was telling Finlay earlier, I only presented this work to sort of like the academic circles. I'm really looking forward to have some feedback from people actually working in aviation and knowing more from the ground. So shortly about myself, I'm a researcher at ETH Zurich in Switzerland. And I'm pursuing a PhD in climate policy, focusing on sort of the relationship between carbon removal technologies, so negative emission technologies, that's the alternative terminology, and sort of all the sectors that have really large challenges in getting rid of their emissions, such as the aviation sector. And yeah, let me share your screen. Today, I will talk a bit, as Finlay already anticipated, about a study that we recently published in Nature Climate Change, which is about sort of the concept of net zero emissions and climate neutrality for the aviation sector. And I subtitled this "The Toxic Relationship Between Carbon Removal and the Aviation Sector," because as we will see, we find out that to get to this climate neutrality framework for the aviation sector, we would have to rely on a lot of carbon removal if we don't go for very strong reductions in demand. So yeah.
Before you start, you were saying the talk, you think maybe 20-30 minutes, and then we should have about half an hour for kind of Q&A and discussion afterwards. Awesome. Exactly. Are you okay with anyone like asking questions as you go along?
Yeah, absolutely.
Cool. So yeah, just feel free to shout out or put something in the chat if you've got a question.
Perfect. You see the right screen, right? Okay, this doesn't look good. Okay, perfect. Okay, so yeah, first of all, I will start with a bit of a broader overview on the motivation of this study and of my work in general, and then I will dive into the details later on. So yeah, we have now piling evidence and decades on research on climate change and mitigation that led us to know more or less what we have to do to get to temperature targets compatible with the Paris Agreement, and especially with the 1.5 degree goal. And according to this cookbook, the first thing that we have to do is to rapidly get rid of our CO2 emissions and get to net zero CO2 emissions by the half of the century. And to do so, we first have to eliminate sources of CO2 emissions in the first place, for example, by switching to renewable energy and electrifying, for example, the heating systems. And then we have to compensate for whatever remaining CO2 emissions we have there. And this is possible, for example, by not only doing offsettings, which are not real compensations, but rather engaging in carbon removal or negative emission technologies, which means we have to remove the CO2 actively from the atmosphere and permanently store it either in biomass or in geological formations, or in the soil, or in the ocean. And this is possible either through quite nature-based solutions, such as just plant trees or restore some ecosystems, or we can also achieve that through more engineered solutions, so to say. Then we have to, then sometimes between 2050 and 2070, we will need to get a step further and also reach climate neutrality. In fact, CO2 is not the only species that contribute to climate change, but we have many others also around there, such as, for example, methane from agriculture. And we have to first focus trying to get rid of these remaining emissions, but then eventually we would also have to use some, deploy some carbon removal to compensate for these remaining emissions. All of these efforts are probably still not going to be enough to get us to the 1.5 degree, which is, however, is very significant to avoid really runaway consequences of climate change. And for this reason, by the end of the century, we will probably need to remediate for overshoots of the 1.5 degree by deploying carbon removal. So by removing more CO2 from the atmosphere than what we emit into it. So what is the role of the aviation sector in this path to get to the 1.5 degree target? So historically, the aviation sector contributes to about 4% of the whole historical anthropogenic climate change. And this might not sound like a lot, but it's a lot if we think about the fact that the aviation sector was at least before the pandemic on a trajectory of very rapid growth, and we are expecting this growth to continue in the future. The problem is also that the aviation sector, and especially the international aviation, it's largely excluded from important climate agreements, such as the Paris Agreement, and also from a lot of national mitigation efforts. And yeah, so in this study I will present today, we investigated how the aviation sector can align to broader efforts to get to climate neutrality. So I first will sort of make a short excursus to discuss the different options that we have at hand to mitigate the aviation sector and try to align ourselves with climate neutrality. So in our portfolio, there are sort of 6 main ways to mitigate the aviation sector, which is through demand reductions, through efficiency gains, by switching to biofuels, by switching to either electric or hydrogen aircraft, by switching to renewable e-fuels, so synthetic fuels, or by deploying carbon removal. And I argue that while the first 3 are very good options that we should immediately pursue since they're already available, they probably will not be able to get us to zero emissions, which is why we will need eventually also these solutions, the latter 3 solutions. Okay, yeah, so demand reductions, I put it on top because I still think is one of the most important things to do. The problem is that it can only do so much. Obviously, for example, even if we would get to a 50% decrease in demand, we would still have 50% of the emissions left there to be tackled. And the problem is that obviously we can't get rid of but the problem is that even getting to large demand reduction is very challenging because of not for everything there are substitution options, and simply convincing people to stop flying and changing their behavior is really challenging, especially in the time frame that we have at hand. And moreover, we don't really have the authority, like no country has the authority to enforce like a ban in the volumes of flights, especially when we talk about international flights, which makes it very hard to govern as a problem. Then efficiency gains is also quite a convenient option, especially because it can also be very cost efficient. But even if we follow the International Civil Aviation Organization target of having a 2% annual efficiency gains, this would still not really be enough to have a real reduction in emissions if we keep on having an annual sectorial growth by 4 to 5%, which is what was historically observed. Then biofuels are also quite like viable options where they are already technologically ready, so to say. But the problem is that, first of all, almost none of them is really carbon neutral because they always emit some emissions while being while being produced. And then also the biomass that we are using can have really large sustainability issues. So it could come, for example, from deforestation and so on. Today we talk about, today we mostly, when we talk about biofuels, we often have better options in mind, for example, coming from waste, like biomass waste. But the problem is that the sort of amount of this biomass that it's available would not be able to fuel the whole aviation sector, and also is in competition for a lot of other uses, for example, as bioenergy. So what I want to say with this is that they are all very good options that, if combined together, could solve probably part of the problem, but not everything, which is why we probably will need to resort to additional options. So electrification and switching to hydrogen aircraft is something that sounds like a very good idea, because especially this option has the potential to really get rid completely, almost completely, of the emissions, and not only of CO2, but also of other stuff. And this is why a lot of companies, such as, for example, Airbus, as I show here, jumped on this technology and is trying to develop new aircraft designs. But the problem is first one of timing. So before we actually will have fleets that are based on hydrogen or electricity, decades will pass, and this is kind of slow. And then we also have the problem that with the current technology, it's sort of unimaginable that we will be able to really fly transatlantic, since there's still like the battery and the volume of like the battery weight and also the volume of hydrogen tanks is too large. So it's rather a solution for short to medium haul flights. Then another newer technology that entered the arena are the so-called renewable e-fuels or synthetic fuels. And this technology has the potential of making aviation really carbon neutral if we would use them as a source of CO2 that was previously removed from the atmosphere. So either biogenic CO2 or CO2 captured through different technology from the air directly. We can then use this CO2 mixed with hydrogen to combine to make e-fuels through different pathways. One of them is, for example, the power-to-X pathways, but there are also alternative technologies such as solar fuels or entrant technologies such as some Silicon Valley startups that claim to do that based on nanotechnologies. Then finally, a possible solution, if we can call it so, is to simply continue emitting, continue flying with kerosene and emitting CO2 and other things, and then capture the emitted CO2 from the atmosphere via carbon removal. And yeah, as I mentioned before, for those who are not familiar with carbon removal, when I talk about carbon removal, I really mean the whole family of methods and technologies that are able to permanently remove the CO2 from the atmosphere and store it either in biomass, geological formations, and so on. And we have now an array of methods that are differently ready to be used, and some are very nature-based, so they could be used, but then they have the problem that maybe there's not a lot of land available to do so, and other technologies that are maybe, so to say, less heavy on land use and on the environment maybe, but they have more, they are more costly and they need more energy. So exactly, so the picture gets even more complex if we start thinking about how to not only get rid of CO2 emissions, but also about non-CO2 emissions and impacts of the aviation sector. And sadly, at the moment, most of the mitigation efforts that are out there, such as, for example, the CORSIA program or the UK Jet Zero strategy, just focus on the CO2 emissions from aviation. But today we know that we have now piling evidence that around 2/3 of the aviation climate impacts are due to non-CO2 effects. And these effects are quite uncertain, to be honest, like you can see it in this figure, this huge uncertainty bar, but we have piling of evidence now that they do actually can matter a lot. And the sad thing is that demand continues increasing, as it's the case in this figure that I show here for an intermediate scenario of growth. the non-CO2 impacts at the end of the century might be well larger than the CO2 impacts. So even if we aim for offsetting the CO2, we would still have a lot of non-CO2 impacts out there that make the aviation sector really not aligned to climate neutrality, which is why we need to start thinking about the possibility of climate neutral aviation and start advocating for it. So on this background, in our study, we first investigated what does climate neutrality mean for the aviation sector. If we take into consideration not only the CO2 emissions, but also the non-CO2 emissions and indirect effects. I wanted to mention this briefly before. When I talk about non-CO2 emissions and indirect effects, I'm talking about all these sort of different things that have an impact on the climate, which are mostly the formation of contrail cirrus, so sort of the streaks of cloud that form behind airplanes, but also other, for example, indirect effects due to the emission of NOx. Yes, so I will now shortly dive into the technicalities of climate neutral aviation, but we'll try to keep it very short. So please bear with me. This is the only part which is a bit more climate sciencey. So understanding, the point that I want to make here is that understanding what climate neutrality means for the aviation sector is not so straightforward as, for example, for sectors that only emit CO2. In fact, CO2 is a long-lived emission, so it accumulates in the atmosphere, which means that the only way for CO2 to be climate neutral is to really achieve net zero. So we have to cut our emission to net zero for the temperature to stabilize it. On the contrary, just stabilizing the emission rates lead to still an increase in temperatures. Yet the situation is different for non-CO2 short-lived emissions and indirect effects, such as, for example, the formation of contrails. In this case, just stabilizing emissions is sufficient to stabilize temperature. And on the contrary, if we get to net zero non-CO2 effects, like short-lived effects, we can observe sort of like a relative reduction in the temperatures, which means that for short-lived emissions and effects, reaching climate neutrality first requiring defining what is the temperature baseline relatively to which we consider the climate to be neutral. And that's what we have done in the first step of our study. So we first try to give definitions of climate neutrality and assess their differences. And underlying all our definition of climate neutrality is the fact that CO2 emissions always need to get to net zero to be climate neutral. So this figure that I showed you before still is valid. But then we looked at the different possibilities for non-CO2 short-lived emissions. And we came up with a first baseline called GOLD, which is the most ambitious one, for which the aviation is climate neutral compared to a world without any aviation. And this means that basically we consider climate neutral only net zero emissions, also of non-CO2 short-lived, which in the end results into sort of a reduction in temperature as well. Then we identified a second baseline, which we call bronze, for which aviation is climate neutral compared to the world at the start of climate neutrality. And by that, we mean that the goal, like the goal of this definition is just stabilizing emissions after the onset date of climate neutrality, leading to a stabilization of temperatures. In our study, actually, we have a third baseline as well, obviously called silver, but this is a bit more tricky to explain, and I think it is not so relevant. These are sort of the two, like the gold and bronze are the extreme cases that are more important to understand these differences. So you will see probably, like you will see it later in the plots, but just ignore the silver definition. And so, yeah, once we defined what climate neutrality means for the aviation sector, we also wanted to explore then how to get to climate neutral aviation with sort of some of the technologies we discussed before. And as we already discussed, fossil jet fuels have both CO2 and non-CO2 warming effects. While, for example, some of the other options we have can manage to get rid either of the CO2 emission, of the two emissions, or also of all emissions. Here today, I will only talk about zero carbon fuels. So carbon fuels such as jet fuels, such as biofuels and renewable e-fuels that manage to eliminate CO2 emissions and also that burn more cleanly and thus reduces some of the non-CO2 warming effects, as you can see in this figure. So we modeled that basically many of the contrast in cirrus formation, for example, or the aerosol would be lower if we would switch rapidly to these fuel types. And then we looked at what would climate neutrality involve in terms of the carbon removal that would be needed to get to climate neutrality. And we would use carbon removal to offset the remaining CO2 from fossil aviation fuels, but also the non-CO2 emissions from both fossil and zero carbon fuels. So in the second part of this
question on that, when you're saying zero carbon fuel and you're talking about biofuels and stuff, so were you assuming 100% CO2 saving from those fuels?
Exactly. This is a bit like the sort of assumption we've done in this study. We just for simplicity in a way, we were interested rather on a scenario where we would manage to get rid of the CO2, but we still would have the non-CO2 to sort of quantify.
Okay, so it's kind of like optimistic in that sense.
Exactly. Like even in a best case scenario, we wanted to show then how much efforts we would still need to do to get to climate neutrality.
Got you. Yeah.
But there's no life cycle emissions in these scenarios, sort of. Okay, then I continue. So and in the second part of this study, we then investigated how much carbon removal would be required to get to climate neutral aviation, and also how sensitive this amount of carbon removal is to different factors, such as our reference point for climate neutrality, so the climate neutrality definition, but also scenarios of future demand or of fuel substitution. And in this study, then we investigated different combination of different factors that can lead us to the climate neutrality. And first, we looked at different, at the impact of different demand and efficiency changes by using different socioeconomic scenarios, which can reduce the emissions from a business as usual scenario. Then we looked at scenarios with a substitution in technology. Here today, I will only present results for this zero CO2 fuel scenario and relatively and compared to a fossil fuel scenario. And then finally, we deployed, we calculated how much carbon removal we would need to comply with our definitions of climate neutrality, either the bronze or the gold one. Okay, so now I will come to some of our results, and I will start from the climatic outcomes of different definition of climate neutrality. So I will show here results only from our intermediate scenario of aviation growth, which is the SSP2 4.5. And in this figure, you can see the warming caused by the aviation sector alone by the end of the century. So we are not taking into consideration whatever emissions happen in other sectors. So on the left side, we see that what would happen without any climate neutrality framework. And this intermediate scenario would lead us to almost 0.3 degree of warming if we would continue just business as usual using fossil jet fuels. And this might not sound like a lot, this 0.3, but actually, if we look at what is the threshold, like the temperature budget needed to comply with the 1.5 degree target, this is quite a lot. This threshold, I think this dashed line is at about 0.03. So this means we are like 1 order of magnitude above this threshold. Switching to zero carbon fuels, even without having any climate neutrality target in place, can help a lot in mitigating the emissions, but still leave us with around 0.1, so about 1/3 of the warming left unmitigated. On the other hand, striving for CO2 neutrality, so just offsetting the CO2 emissions, doesn't help as much because it manages to mitigate only about 30% of the original warming. Which is why we then looked at the climate neutrality more broadly. And we observed that for just simply stabilizing the aviation impacts after the onset of climate neutrality in 2050, which corresponds to the bronze scenario, it still leads to some overshoots of our 1.5 degree compatible threshold. So the gold climate definition is really the only one that manages to drive temperatures below the threshold, since after 2050, it really drives aviation emissions to net zero.
Could I just check where you've got like the blue is fossil jet fuel and the red is zero CO2 fuels?
Exactly.
Is the assumption that like from the year 2022, 100% of jet fuel is the alternative fuels, or do you
exactly
phase it in a certain, like ramp it up?
Yeah, exactly. We have a sort of S-shape ramping up from 2020 to 2050. So we imagine that in 2050, which is very optimistic, we would have 100% sort of drop-in ratio of zero CO2 fuels. So
do you know, just out of interest, like in 2030, what, like, in order to get to 100% by 2050 with that S curve?
I think it really has a very steep S curve, if I remember correctly. I don't remember exactly the rates for 2030, but I couldn't.
That's all right. Yeah, it's quite a specific question. Thank you.
But yeah, I think like in my memory, it was going quite flat, and then having quite a big of a jump between 2030 and 2050, I would say. Like 2030.
Cool, thanks.
So yeah, so I think up until 2030, there's not a lot happening, if I remember correctly. But yeah, okay. So yes, if there's no more question, maybe I go on. So to get to these temperature outcomes that I just showed you, a part of the residual emissions needs to be offset with carbon removal to get to the climate neutrality definitions. And we see here the mean CO2 removal rates that we calculated to comply with these temperature outcomes in gigatons CO2 per year. And we see the first thing that carbon removal is needed across all definitions of climate neutrality, and also all scenarios of demand, so also in the zero CO2 fuels scenario. And the rates are however very different, and especially they're very high for fossil jet fuels, and especially for definitions such as the gold one that are compatible with the 1.5 degree budget. Switching to zero CO2 fuels can, however, help a lot to reduce this amount of carbon removal that we would need by reducing it by around 60%. So now to put these numbers more into perspective, because I guess just saying 5 or 7 gigatons CO2 doesn't help a lot, I briefly calculated what that would mean if we were to cover, like to remove all the CO2 by planting forests. And we would need it just to achieve 5 gigatons CO2 per year to cover the whole surface of Germany in forest. And we can even observe that actually the gold scenario is even 50% higher than that, which means that that we would even need 1.5 Germany to comply with that scenario of keeping off burning.
And that's per year, right? So you need to cover Germany again the next year.
I mean, like I guess. Oh yeah, I think a forest is. I think it was like the amount of CO2 that a forest removes per year, what I calculated. So I think it would be just like planting it once and then, yeah, but it doesn't make sense. No, maybe you're right. Yeah.
it might be like, I think it's just not possible to cover
exactly
the world in that much trees, right?
Yeah, exactly. I mean, obviously there are other carbon removal options that would be available, but this is just to give you a feeling of what extents we're talking about. It's like, and yeah, exactly. There's really a lot of carbon removal. And what I wanted to show you is that now I showed you these results only for sort of an intermediate scenario of demand growth for aviation sector, but the picture gets even more gloomy if we look at other scenarios. Here, for example, for this very pessimistic actually scenario of demand growth, where aviation just keeps on growing exponentially, we would need 2.3 of the times the surface of Germany. And even switching to to a scenario where the demand is sort of stagnating after 2020, we still need a lot of carbon removal if we keep on flying with fossil jet fuels, which corresponds more or less of a forest covering the surface of Greece. But since we know that what happens in summer in the southern of Europe, this is obviously not a really good idea. So this is just to say that not tackling aviation emissions and non-CO2 effects at the source has very large implication on the climate, which would need enormous amount of carbon removal to be counterbalanced. So also the different definition of climate neutrality are possible and their implications are different. So I would like you to be aware of the baseline whenever you're considering an aviation net zero target or climate neutrality target. And finally, I showed here that in scenarios with demand growth, carbon removal would be unavoidable, even if we would be switching to zero CO2 fuels quite rapidly. And this would, however, not be the case if we combined all possible mitigation options with decreases in demand. So we could, and that way we would be able to sort of make this toxic relationship between the aviation sector and carbon removal way less, way healthier in a way, and just reduce the amount of carbon removal. Okay, and with this, I came to my final slide. And yeah, as I said at the beginning, I'm very happy to hear your feedback from a very different perspective, I guess. Thank you very much.
Thanks, Nikki. Yeah, that was really interesting. Yeah, I guess it'd be great if people do have questions, you can put them in the chat, or yeah, just raise your hand and I'll kind of take it in order. I can start with one though. I mean, I've probably got a few, but I was just thinking on your zero CO2 fuel. You assume that reduces some of the contrails as well?
Yes.
What sort of percentage reduction do you give it?
I can look at the assumption we've made, but they were sort of, I mean, we kind of had quite optimistic assumptions on this. So they were based on a recent study out of I think it's the German Center for Aviation and
yeah, that's DLR.
DLR, exactly, and they published a study where they basically went up and measuring the emissions and the formation of contrails from different sort of sustainable aviation fuels, and then we sort of like scaled these emissions reduction that they measured to a hypothetical scenario with 100% of synthetic of sustainable aviation fuels. And if I remember correctly, the reduction in contrails were something in the magnitude of minus 30% or minus 50%. Yeah. But it's definitely in the supplementary information of the paper, so I will definitely be able to look it up.
Okay, no, that's all right. Thank you. George, do you want to go first? And then we've got a question from someone else in the chat.
Yeah, thank you so much for that. That was really interesting. Throughout your research, what different types of carbon removal did you study, and which were found to be more effective than others? And do you foresee that we'll have to actually have a big step up in carbon removal technology to achieve any of that climate neutrality?
I mean, we do have, like, it's really a matter of trade-offs, and I see here in the public there is also Cyril Bronner, which is the real expert on the different type of carbon removal methods. And I mean, the point, like here in this study, I really kept it broadly. So I didn't differentiate in technology types, but the issue is that you have a lot of trade-offs. So you have sort of technologically like readily available methods, like simply reforestation or wetland restoration and so on, which have a lot of other benefits, but also they would require a lot of land, which is at the moment in competition for a lot of other uses. So they would put a lot of stress on land use, and possibly this can conflict with food production or energy production, or even simply nature conservation and so on. So I think this is sort of a family of techniques that has a lot of benefits, but also is problematic. And also the permanence of the CO2 in this sort of technology, like in this sort of things, is really not so long-term as you can achieve with, for example, geological storage. Then we have the whole family of technology that relies on geological storage. So for example, bioenergy with carbon capture and storage, and direct air capture. And both of them are like, I mean, for the bioenergy parts, we have the same problem with land use, which means having to have crops and so on, or taking the biomass from waste. But still, as I mentioned at the beginning of my talk, we have a lot of problems in using, like, I mean, there's a lot of competing uses for this biomass. So we would need to have very good practices of like cascading use of this biomass in order to make it sustainable. And then, I mean, there are many other techniques that DACCS comes out a bit as a sort of dream of the carbon removal, because ideally you would be able to remove CO2 with very little land use, and you would be able to do it anywhere. And if you would couple it with renewable energy and put it at optimal location, could be feasible. The problem is that it's incredibly expensive, and as we were talking before with Finlay, it's very unclear who will bear the cost of demonstrating and sort of making this technology develop and increase and decrease the cost. So to get to a point where it's actually feasible to counterbalance the emissions with direct air capture, and possibly if governments wouldn't take a leadership role on this, it's going to be very hard to see this happening at all, which is why it's sort of the problem sometimes with carbon removal, that it's easy to bring them in modeling, exercising, but then it's very hard to actually get them on the ground and going, and this can create sort of mitigation deterrence and promises. And this is something, I mean, I personally, in the study I've done, I just showed you the numbers. If we were to not tackle the aviation emissions and just rely on carbon removal, is something that we might want to do, and it might even make economic, like it could even be cost efficient, but then we would lock ourselves in sort of a situation where we are promising to remove emissions while we are not reducing them, and then that could possibly fail, right? But I don't know if this really answered your question. I think I went a bit.
You kind of had two parts to that question, George. Did the second question get, what was the? It's all right.
I'm trying to remember what the second part of the question was. The first bit was like, what were the different types and how effective were they were? Yeah. And I just can't remember the second bit. If it comes to
That's
me,
all right. We'll go on to the next one. If you want to think of another one, we can ask that.
Okay.
Just wanted to make sure. So we'll go. Drayton in the chat is asking about the different socioeconomic scenarios. So when you had your demand growth and you had 3 different scenarios mentioned, you kind of didn't sort of say what the difference was between high, medium, low. So I think he was just wondering, like, what are those growth rates, and does it continue past 2050?
These are, again, I'm very sorry for not being so prepared on these numbers, but I actually, like, this paper was published a couple of weeks ago, which means that the last time I actually worked at the manuscript was forever ago. And these are all the details information that are in the supplementary information. So I do have a table with the demand growth in different scenarios, but I really don't remember them by heart. But I'm very happy to send you the access link to the paper and the supplementary information. But in general, I mean, I looked at very sort of extreme scenarios. So I took like the possibly most pessimistic scenario of climate change, with a very steep growth of the aviation sector, and then another sort of boundary case where the demand was sort of stagnating and decreasing a bit. And in both cases, past 2050, there are changes in demand still, which is why we sort, like, in the opposite case, my bronze definition even make sense, because demand would just stay, so emission would just stay there, while we do have these changes in demand past 2050 that we account for in the climate neutrality then efforts, so to say. But yeah, happy to.
Okay. Gregoire, you've got a question.
Yeah, hi guys, can you hear me?
Yeah.
Okay, well, thank you. First, thank you so much for the presentation. I got a couple of, let's say, general methodological questions for the future. Well, going back to what you said on the Paris Agreement Objective Cookbook, where we need to be CO2 neutral first and then climate neutral second. I'm questioning the idea of reversing those objectives for the aviation sector, because we all know that all the technological options for decarbonizing the sector will not come into effect before, let's say, 2035, 2040, or maybe later. Whereas there's a couple of options that we could activate in a shorter term to tackle the non-CO2 effect, especially contrails. I'm thinking about operations, optimizing trajectories, operations, removing the long carbon chains in fossil fuels by aromatics, by bringing some hydrogen into the fossil fuel, etc. And my feeling is that the sector is not comfortable with reporting and communicating on those initiatives, because they are lacking from a method for comparing CO2 and which are long-term and non-CO2 effects, such as control with very short-term effects. So here is my question now. Do you think that your definition of climate neutrality for aviation, which, if I understood your point correctly, is to say what is the extra level of carbon CO2 removal that we need to bring into the place to compensate the non-CO2 effect, is somehow expressed in a CO2-like measure. So would it be a kind of way to provide the sector with a kind of like equivalence between to compare non-CO2 and CO2 effects, and then to provide a sector with some levers to decarbonize, or to not decarbonize, but to lower the climate effects of aviation by bringing some kind of a common measure? I don't know if I expressing me correctly. Let me know what you think.
Yeah, first of all, thank you so much for bringing up the changes in operations, which I think it's really the one mitigation option that I did not mention, and I think it's a super important one, and it could be very, very useful in the short term, because it could really sort of exactly do what I showed, like sort of like decrease the short-lived effects, which means reversing a bit of the damage we already have done. And I think this is a very important option that should be investigated more. Then about our methodology, I mean, in a way, yes, we do in a way relate the CO2, so the carbon removal with the non-CO2 impacts, but we do this in a very hard to operationalize way. So for example, many companies like that offers offsetting, such as, for example, MyClimate, they simply, to calculate the non-CO2 impacts, they just use a multiplier of the CO2 emissions. So they just say, okay, CO2 is 1, and then the whole of the aviation effects are 2, for example. But what we've done was, since we kind of know that this relationship between CO2 and non-CO2 is really dependent on sort of the trend of emissions, this doesn't really apply for future scenarios. So it's okay not to do it so now for a single flight, but it's really not okay to do it in the future with changing technologies and so on. So what we've done is to basically, like it's kind of we applied a method to sort of come from the effective radiating forcing of the non-CO2 emissions to sort of the CO2 equivalent based on an alternative use of the GWP 100. I don't know if you know, but it's a metric like this. The alternative use, it's based on looking at the changes in the rates of emissions and the changes in the ERF. And what we found in our modeling is that obviously this method is not perfect, because you're always having sort of a lag since you're looking at the changes. It's also, yeah, I mean, you also have it's not one, like the relationship is not one-to-one, it's not perfect, but it's kind of a good approximation. But the only caveat is that it kind of is only possible to do so when you look at the whole volumes of aviation. So you have to know all emissions to sort of be able to calculate the CO2 emissions that you would have to take away to counterbalance for it, which I guess it makes it very complicated for single airlines to know what is the benefit. So I sort of don't think that our methodology would really solve this problem. I think we were probably, yeah, I mean, we used it to calculate the offsets in a way that it's not the standard one of just using a multiplier, but I don't know if it's then applicable to single flights. In one of our like at a point we tried to sort of calculate the cost, the additional cost per flight of the carbon removal, and what we've done was to try to look at the whole carbon removal that we need divided by the old kilometer flown in a year, and then sort of look there at the benefit. But I think it's still you would need to know the whole of the aviation volume, so I wouldn't see how it would work with a single flight, to be honest.
Just a specific point on that before I take Carlos's question. Do you assume that like the non-CO2 impacts are distributed uniformly across all flights? So like what we know in reality is that like 10, 15, 20% of most flights produce the vast majority of non-CO2. Yeah. So for example, you could apply your low aromatic fuel, synthetic fuel, to like the 20% of flights and maybe get a halving. Let's just say it's a 50% reduction of contrails. You could, without doing any route changes, you could half, say, let's just say 20%, create 80% contrails. If you apply the fuel just to those 20%, you'd half 80 down to 40, so you'd get like a 40% reduction just from applying it to the 20%. Do you know what I mean? Yeah. I guess that's not considered, right?
Exactly. We really did not consider changes in like the way we account, like we did not account for single flights. So we just basically looked at the historical relationship between the trajectory, like the kilometer flown with the climate impacts. So we kind of made an implicit assumption that the trajectories, like the routes, would be more or less the same, but with more demand, which is obviously possibly not true. Like obviously if we would change routes and we would fly more, but in other regions that we would have very different routes. But we had sort of no way of modeling this. It would have been very helpful for us to take into consideration changes in operations, which is why at the end we opted for leaving out this aspect. But it's a very good point, actually. Yeah.
Good. Thank you. Yeah, good question. Carlos, do you want to ask your question?
Yeah, thanks, Finlay, and thanks, Nikki, for the presentation. I think it was very good, and it's always good to have a look at the aviation sector a bit from the outside, because you see things with different eyes, and sometimes we're like very biased from the inside. So somebody coming from the outside and looking at the entire situation and how can we achieve climate neutrality, I think it's really good. My question is, I've really liked the comparison of if we want to offset 5 gigatons of CO2 equivalent, we need to reforest the entire Germany. So first is maybe about the methodology. So what type of I guess you've used a type of maybe average forest or something like that. Mm-hmm. And then if you know of anything like a quick simulator that could give you that type of figure, because I think that's the way of conveying to the public that sometimes the aviation industry sells guilt-free flying with buying offsets, and people think of reforesting. And this is a way of telling the general public, this is absurd and this will not happen. Yeah, exactly.
Yes, I mean, to be honest, this was a really back of the envelope calculation that I've done just for this presentation. I just basically, I think I really honestly took like the look at how much CO2 would a average forest in sort of the latitude of Germany would sequester. Like I think, yeah, I don't know the type of forest, the name, but the sort of like for this type of climates, and just looked at how much CO2 is usually stored per year. But it's a pretty coarse calculation. So I wouldn't be surprised if you would repeat this calculation and find quite different rates. But yeah, I haven't found any good calculator for that. I was looking for it, and I think most people that use this kind of figures are NGOs and campaigners that I think they also do something similar to what I've done, just looking at what it means.
Thank you. Dennis?
Sure, thanks, Finlay, and thanks, Nicoletta, for the presentation. I think to Gregoire's point that was mentioned earlier on non-CO2, just because, again, I guess just like Carlos, I come from the inside of the industry, particularly from airlines, and I'm keenly aware of how reluctant they are at the moment to kind of participate in the discussion about non-CO2 effects. So in terms of measuring those in any of your scenarios, if you future scenarios, how much engagement from airlines do you assume there's going to be? Or rather, is it the case where you think it's mostly going to be the ASPs and other bodies providing that information?
About the non-CO2 effects?
Yeah. Particularly the data on the calculations.
I mean, the data I use is based on their modeling projections, and for the historic data, I use the data based off a paper that came out last year, which is called, like, it's from Lee.
David Lee.
Yeah, David Lee is a quite famous UK-based scientist. And I honestly did not have to engage then with airlines or other bodies, so I wouldn't know exactly. But I could imagine they're pretty, like, it's pretty hard to get this data from there. And the problem is, even like, I mean, probably you would get, even if you would get data, you would get data for the emissions, but then you wouldn't know exactly the formation of contrails, for example, since they really depend on the routes and so on. So I think you would need a lot of, which is why usually the assessments of sort of these things are based on like remote imagery or just, yeah, the relationship between the kilometer flown and the observed changes in the radiative forcing, so in sort of the warming observed. So I wouldn't really be able to answer your question because I honestly really haven't engaged with neither of these bodies, so airlines and so on. Yes.
George?
It's not really a technical question, it's more non-technical. How optimistic do you feel about the future of these projections? How optimistic do you feel that the gold scenario is likely to happen, considering the amount of greenwash in the industry, the toxic relationships between fossil fuels and governments, the fact that airlines are mandated to grow every year? How optimistic do you feel that we can undo all of that, all of those links?
I feel incredibly pessimistic, I think. And I was even shocked because obviously you would expect a lot of friction from airlines and this kind of factors, more industry side actors. But what I noticed is even from sort of the climate community, I got quite some critiques to the fact that I'm trying to claim that climate neutrality is not just the stabilization of temperatures. Like, even my assumption that we could see net zero short-lived emissions as something we should aim at, I even got critiques from some scientists about it, because they say that, and it's sort of true, that even in the scientific community sort of established that climate neutrality just means staying stable. So my sort of the gold definition of climate neutrality is even too ambitious for people working actually within the research for climate mitigation. And for me, this is very unsettling, because then while crunching the numbers and making the modeling we did find out that only the gold one is sort of what would be compatible with a 1.5 degree scenario. So even if it should be very obviously what we should aim for, it sounds very much out of reach in a way. So I do feel quite pessimistic about it.
Oh, sorry, George, go ahead.
As a follow-up to that, what do you think people in the industry, in the scientific community, the general public can do in their respective fields to push the gold standard or your gold scenario forward? What more can we do? What do you think we should focus on to really try and make sure it does happen and it's not just a pipe dream?
I don't know. The first answer comes to my mind. It's the typical cheap scientist answer of just like, oh, spreading the word that it's so important to get rid of the non-CO2 emissions. But as we all know, like we have been like the issue with climate change and all the harm we do has been around for ages, and we know that it's not that alone that triggers action. So I honestly think probably a very good ally in this sort of campaign to spread the fact that getting rid of emissions is what we should do and not just stabilize them or so are people working for the electrification of the aviation sector or for hydrogen airplanes, because they kind of have an interest like to sell their technology. So they might be at the end allies of this kind of discourse, because they could advertise their technology as being the only one that can get us to a place that is compatible. Then in the end, I personally believe they won't manage in the right time. So we also have to trade off the fact that, yeah, we shouldn't be relying only on a technology that is going to come, if at all, in many, many decades. So I think I see it very, yeah, I wish I could answer this question better and I would know what to do. For me at the moment, personally, is trying to talk to you is what I what I do to try to push this message forward. But yeah, I don't know.
Well, we're always, Safe Landing will always be here if you come up with any good ideas. We'll look to put them into practice. Sebastian in the chat has asked if you could ask a question. Do you want to?
Yes, hello, good evening. Can you hear me?
Yes.
Yeah.
So thank you for the presentation, Nicoletta. It was very interesting. I discovered you guys through Captain Todd, for his full name, but Todd Smith, in a way. I wanted to ask a question that's more, maybe a bit more philosophical about aviation, because you presented all these challenges that the industry is facing regarding its emissions. But should we just keep flying in the first place? Because only 10% of global populations flies on a regular basis. So flying is really a privileged activity in a way. And we know that we're heading toward an energy crisis. We're already in a climate crisis. Do we really need to pull these resources towards aviation? Because many of the solutions I feel that you presented, like you seem to show that there are still many challenges ahead, and even yourself seem to be very pessimistic about your chances to meet the best expectations of your provisions. So I wanted to ask you, like, how do you feel about the future of aviation as an industry itself?
I mean, I personally really believe that since we know how many challenges are ahead, in any case, like demand reductions is a huge priority, and it should be what we should push for in the short term, for sure. I kind of sometimes look at this problem more like as a scientist. I do see the pragmatical side of it, which is we know behavior changes are very hard, and even if you're talking about just the 10% of the population, it's going to be very hard to manage to reduce this number and make less and less people flying, which is why then for me it's important to also look at the different options, since we would probably need to fall on some of them realistically. But I totally agree with you with the fact that it's a privilege, it's a luxury to fly, and it's a very, very harmful luxury. So in a way, I think and I saw that you at Safe Landing, for example, really push forward this message, and I'm very happy to see workers in the aviation sector standing behind this message, because it's something that I think it's probably our best option in the short term.
Yeah,
Better
you might be
reality.
interested. There's a couple of Gregoire and maybe one other are from. There's another group called Aero de Carbo in France that worked with the Shift project, and they did a similar a report looking at different scenarios, and yeah, showing that if we continue with current growth, by the mid 2030s, we will have completely blown the carbon budget by then. So yeah, like I think just getting aviation people that work in the sector to just acknowledge that reality. So many people are in denial about the fact that we might actually need to limit how much we fly. So that's a key message that's front and center. And we think that is actually, facing reality is fundamentally going to be better for the industry and better for workers in the long run.
In the long run, yeah, for sure. Yes.
And we've put our website in the chat. So if anyone is here and isn't part of the group and would like to join and get involved, as well, if anyone is here and they're from outside of Safe Landing and they think that they could give some external expertise, like you're talking about, I think like something that our group is very interested in is this dynamic between distribution of resource, so biomass and renewable electricity between different sectors, and that kind of cross-sector understanding. If we're going to need to do some negative emissions, we're going to need to produce some hydrogen for some things, we're going to need to try and electrify lots of other sectors. How much renewable energy and biomass are we feasibly going to have in 2030, 2040, and therefore how much can aviation reasonably assume? That's actually a big question that's never been answered, and no one's even really, as far as I can tell, like attempted to answer that question. And our industry sort of assumes that it can have all biomass everywhere to make biofuel. So we'd really like to challenge that one in particular. And if anyone in your department or whatever thinks that they could do a good presentation on that, we'd love to hear it, or would be interested in working on that sort of question. That's definitely something we'd be interested in.
Great. I actually, a person in my group actually does work on biomass and biofuels. So I don't know exactly on what, but I think she does some sort of modeling of the allocation within broader decarbonization efforts for Europe. So I think she might actually be a good person to talk to. I will
Awesome.
consider.
Okay, well, yeah, thanks again for just coming along, spending some time with us, and yeah, just a really interesting presentation and some great questions from people. So I found it really, really interesting, and I hope it's been good for everybody else too. So yeah, thanks everyone for coming.
Yeah, thank you very much. I will also maybe share with you the PDF of the paper, because I don't think it's available open access for everyone. So
okay,
yeah,
that'd be great. And I've got your slides from you, don't I? So I can share that with the group.
Perfect. Yeah.
Perfect.
Great. Thank you. Bye bye.
Thanks, guys. Have a good evening.